A manager wanted to analyze the time taken by his production workers to complete specific tasks. He randomly selected 30 workers and noted down the time in minutes these workers took to complete a task assigned. So all these numbers are in minutes. So the first number is 13. 13 minutes, 30 minutes, there are 30 numbers here, 30 people, 30 workers. So everyone will have a number. How long do they do the task? So from 30, some 21, some 28, some 34. Now look at the first question here. Is the data qualitative or quantitative? Is it a number? Very obviously, it is a number. Discrete or continuous? Is it discrete or continuous? Okay, let me see what's your response. Okay. What's your response? It is about the time taken to finish a task, right? So is it discrete or is it continuous? Go on, go on. Yeah, give it another 5 seconds. 5, 4, 3, 2, 1. Any more? Okay, let's see what's your response. Majority say discrete. Some say continuous, but even a bigger majority have not responded. So how do you define a discrete number? A discrete number is defined as discrete is because if you add decimal, it will not be meaningful. A discrete number is not by the look of it. It is the nature of it. That means if you add decimals, it doesn't make any sense to you. So this is time, right? Can you add decimals to it? Yes. But if you wish not to show, it's still time, correct? So it doesn't matter whether you show in decimal form or you don't show the decimal part. You still can add decimals, right? So the answer is continuous. So the answer is continuous. Okay, right, back to this. Answer is quantitative, continuous. Are you clear why continuous? Remember when we work through this portion, you say that quantitative are numbers, so fine, they are all numbers. But this number, is it discrete or continuous? It all depends on what's the nature of it. It is a time in minutes. Can you have decimals for time? Yes, 3.57 minutes or 28.25 minutes. You can add decimals if you want to, and it is still makes sense. Okay, if you put decimals, it still makes sense. Then this is considered continuous. Right. B. Is the data nominal, ordinal, interval, or ratio? These two belongs to qualitative, which is not number. These two belongs to quantitative, which are numbers. Time, does it have a true zero? Ratio must have a true zero. Does time has a true zero? Before you start calculating someone's duration doing a task, what is the starting point of a stopwatch? Zero. So that is a zero starting point. We call that true zero. So time is ratio level. So this is the first half of the topic 1. Next one. Can you find out the mean and the median of the above raw data? Okay, find out the mean. How to find the mean? You can work out the mean somewhere, anywhere in your exercise book, or you can work out, if you have printed this, you can just work out at the side here. What is the mean? Okay, mean is just x bar equals to summation of x divided by n, right? Right, take a minute, add the numbers, add all these numbers together. You know there are 30, so we're going to divide by 30, but I need you to add all these numbers. Done? 30 numbers. What did you get? Yep, you already gotten the mean, right? 22.13. Okay, so what is the total? The total is 664. So what you do is you just write that equals to 664, and there are 30 numbers, so you get 22.13. Good. So now you're going to go to the median. Before you can find median, you must arrange the numbers, all the data from the smallest to the highest number. Don't worry, there are 30 numbers. They already arranged for you, right? It's already arranged. So you have to use the I formula will be much easier because there are so many of them, right? So the I formula to find median is half n or 50 over 100, okay? So half n. So you get 15. Anyone already gotten your median? What is a median? What's a median? No one has a median yet. 22? Yes, this 22. Good. Most of you gotten. Yeah. Okay, so I go back. 15. So according to this rule, the I median index, the median, when you get an I which is equals to 15, means you're going to go to 15 number. Then you add the 16 number. One more, right? Then you find the average of these two. Okay, I better don't jumble this with here. Will be 15 plus 16 divide by 2. That will give you, what is a 15 number? It's not difficult to calculate. This is 1, 2, 3, 4, 5, 6. So 15 is this one, 16 is this one. So 15 plus 16 divided by 2 is still the same number, right? 22. 22, just to show you, it is also 22, so it's 22. Right, based on these two numbers, 22 is median, and you have this one is the mean. Oh. What can you tell? Mean is 22.13. Median is 22. Are they quite equal? So if they are quite equal, let's look at those who are ready. Just look at the question and see how you answer the question. I have to leave it a little bit long just in case other students still looking at this. Okay, now we go up here. Find the mean, done. Find the median, done. Okay, this one done, this one done. What do you think the shape of the histogram will be with the two values of mean and median? Is the shape that you expect for this set of data is bell shape, right skew, or left skew? Compare these two numbers. What do you think? What's your response? Left skew? Others? Other response they have? 22 and 22.1. You remember that when you have actual data, it's hard for you to get exact number. So is 22 and 22.1 considered different, or they are almost the same? Is 22 and 22.1 different, or you can consider them almost the same? Okay, let me go through with you where you actually get all the answers, yeah? So the left skew seems to be the highest. Okay, let's look at the slides. This is the one that I'm asking you. Which shape do you think the data is? If the mean is almost equal to the median, then it should be symmetric. Symmetric means bell shape. If the mean is bigger than the median, then it should be right skew. If the mean is smaller between the two, then it should be left skew. So which is the one? Is this correct? 22 and 22.1, are they different in the first place? Are they different? Point 1 minute. So do you think they are very different? We can say that they are almost the same. Okay, they are almost the same. If they are almost the same, then which shape do you expect the graph to be? Almost the same. Okay, so let's go back here. Oh my, it's a good try. Right, so the mean is, I'll just write down here, easier to see, 22.13. Median is 22. 22.122, the difference is just 0.1 minute. So we can say that they are almost the same. So when they are almost the same, then you expect to see a graph which is bell shape. Bell shape means symmetrical. Okay, right? Are you convinced? Any question up to here? Okay, if you want to know how different is different, you just take the difference divided by the original number. So let's say you take 0.1 divided by 22. How much is it? 0.1 divided by 22. You get something very small, right? So you can take 0.1 divided by 22. Sorry, I'm not typing anything. 0.1 divided by 22. So you get some number which is very small. So the difference is very small. Okay, the percentage of difference is a percent of difference, which is very small, which is just, how many percent is it? 0.0045 times 100%. So that will give you 0.45. Not even 1%. The difference is not even 1%, so it's considered a very small difference. So if the difference is very small, then you can consider that is almost the same. Okay, so if they're almost the same, then it will be bell shape. Right, so back to the question, bell shape. Now, let's construct a frequency distribution table, then draw a histogram for this data and see whether it is bell shape or not. Right, so first of all, let's fill out the table. We're going to do a frequency distribution for the table starting from 10 to under 15. So what's the next number? Under 15 does not include 15, so the next number should be 15. Okay, to under 10 to 15 is plus 5, so 15 plus 5, 20. So you have 20, start again to under 25. 25 to under 30. So 30 to under 35. Okay, now you do the class midpoint. Class midpoint is just an exercise, yeah, so that you get used to it, because it's something very common in exam questions and in a tutorial question, in a quiz. 10 plus 15 divide by 2 give you 12.5. Figure out the rest of the class midpoints. So you get 17.5. Next, let's find out the frequency. Frequency is quite easy to find out because it's already arranged for you from the smallest to the highest. So figure out, just take 1 minute, tell me what is your frequency and see whether your frequency tally with mine or not. Do you get 3, 7, 10, 6, and 4? The total to be 30. Calculate the relative frequency. Relative frequency, that means with reference to the total, how much is each of these? So 3 divided by 30, find out. 2 decimal will do. 7 divided by 30, the rest all divide by 30 and see how much you get. You got this? Okay, total up and see how much you get. Do you get a 1? Now we have a lot of 3 threes. 2, 3, 3, 3, 3, 3, 3, 3, 3, 3, 1, 3, 3, 3, 3. So we end up with actually only 0.99, right? Just leave it at 0.99. It's actually quite close to 1.00. See that we only have 2 decimal places. If we have another one, there will be 0.999. So we're even closer to 1. Yeah, just leave it as it is. What is cumulative frequency? The first one is just a 3. The second one, 3 and 7, give you a 10. Then continue on. 3 and 7 and 10 plus another 10 will give you 20. Plus another 6 will give you 26. Plus another 4 will give you 30. Don't put anything here. The addition of this has no meaning. Same thing for the midpoint. Don't put anything at the midpoint. Cumulative relative. Okay, so just take note of the word relative. That means you're going to find the ratio. Relative. So you're going to find the ratio again. So 3 over 30. Now you have 10 over 30. The next one we have 20 over 30. Then you have 26 over 30. And the last one, of course, is 30 over 30, right? So 26 over 30. Zero 0.87, and this will be 1.00. Don't put anything here, cannot add. So we are done with this. Construct frequency distribution. Next, we are going to draw a histogram. Histogram will need this and this. Let's draw a histogram. The highest point for the y-axis is 10. And we have 5 classes, right? Okay, so let's draw a histogram. Are you done with this? If you are done, please draw the histogram now. Okay, I scroll down. Let's draw a histogram. You have 5, so you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is time in minutes, yeah? Put class. Okay, so this one is start from 10 to 20, 15. Okay, so they share the border, so it's 10, 15, 20, 25, and 30, 35. Here will be 2, 4, 6, 8, 10. Enough. Right, the last one is a 0. Then the first one is 3, then 7, 3, then 7. 7 is here. 10, 6, 4. So the next one should be 10, and 6, and 4. What do you think about the shape? Is this symmetrical enough? We can say this is symmetrical. Okay, so this is considered bell shape because both sides are quite balanced. In practical sense, you cannot have exactly equal height on both sides. As long as it looks normal, it looks quite balanced on both sides, then you can say there is almost symmetrical. Right, so for this particular one is symmetrical. Then you answer the question above. You answer the question above. Draw the histogram. Done. Okay, draw the histogram. All done. Then what's the shape of the histogram? What's the shape of the histogram? Bell shape, right? So just write bell shape for part C. The histogram, what's the shape? The shape is also symmetrical or bell shape. Symmetric or bell shape. Compare your answers in 2B. 2B is this one. What did you say? You say bell shape. And 3C, what did you say? Bell shape. Are they the same? Yes, they are the same. So what does it mean? It shows that when you have the mean and the median, they are almost equal, then you should have a bell-shaped curve. Right, so this is just a very small set of data and you can see the effect already. Okay, right, so just remember whenever you see a mean and median almost the same, you expect that when you draw a histogram, you draw a polygon or you draw a graph, it will look like a bell, balanced on both sides. Now let's answer this question. What is the percentage of workers who complete the task within 25 to under 30 minutes? What is the percentage of workers who complete the task within 25 to under 30? 25 to under 30. 25 to under 30. How many of them? 6. What is the percentage? The question is asking about percentage. So what's the percentage? 6 out of 30. That will give you 0.2, right? This is proportion. You multiply 100 will be 20%. Clear? Right. So I prepared two more data set at the back. Set number 2 and set number 3. So I want you to repeat, not the whole thing altogether. I want you to repeat question 2, 3, and 4. 2, that means find the mean and median for data set 2 and see which is bigger or which one is smaller or they are almost the same. Then you check whether it's bell shaped, right skewed, or left skewed. Then you construct the frequency distribution following the same class. Okay, following the same class. You do not need to do the midpoint all over again. Just leave the midpoint empty. You just need to fill up the frequency based on the data set, then do a calculation of the relative just as exercise so that you are more well versed with these columns. Okay, then after that, draw another histogram for set 2. Then repeat the 2, 3, 4 again, 2, 3, and 4 again for set number 3. Okay, so you can I'll let you do now. At the same time, you can actually go for a 10 minutes break, or while they are doing, right, you may want to have some snacks with you. You may do it. Yep. So I give you 15 minutes break and another 15 minutes for you to do this. So I'll see you later. Right. So once you got it, then we'll check our answers. Then we conclude this. Okay. Then we can go on to the next part. Okay. So now is 4 o'clock, 37 minutes. So you take another 15 minutes to take a break and 15 minutes to do these two exercises, set number 2 and set number 3. So it's about half an hour. So I'll see you 5:08. Okay, make sure you finish it during the break. Not really a long break, but you need to complete this task. So take a 15 minutes break. Then continue to data set 2 and set 3. We'll check, we'll go through the answers at 5:08 p.m.